Hello, everyone. We're back from the AWS Summit in London, and I'm joined by Niraj, which is an expert in IoT, but a different case that we just talked about the industrial cases. Now we are going to talk about machine learning, and more importantly, doing that on places where you probably wouldn't expect, right?
Absolutely.
So could you tell me a bit more about yourself and what's your role?
Yeah, so my name is Niraj Kumar. I'm a solutions architect at AWS based in London. And yeah, so I work with customers. That's my day job, helping customers make best out of AWS platform. And my key interest from technology perspective is, as I said, IoT and machine learning are two, yeah.
So when we talk about machine learning and IoT, it's usually two different spaces, right? When we talk about IoT, it's usually the small devices, the Arduinos, the Raspberry Pis, and this kind of scenario. When you talk about cloud and machine learning, it's usually like huge training clusters and GPU and a totally different kind of thing. Could you explain a bit more of where these things meet?
Sure, absolutely. So you're right. I think when it comes down to, if we break down the process of creating machine learning models, the very first thing you need is data. With data, you need often, depending on the kind of problems you're trying to solve, if you're trying to build a deep learning type of machine learning model, you often need a lot of compute power as well. So cloud definitely is the best place. I think you may have heard from the previous speakers as well. Cloud provides you that virtually infinite scale from a storage and compute perspective, and you can do this in a very cost-effective manner. So that's the place you would typically train your models. But the second half of the story, once you have trained your models, you can deploy them in the cloud. You can also now, with something we'll go much deeper in today's session, you can also run these models on the edge devices. And it makes sense for certain use cases for that intelligence, that machine learning model to actually run on the edge. And I think we have talked about some of these use cases, some examples in the past, but some of the common ones I can call out is, think about a connected car, an autonomous car. It can't
that's
function.
a huge one.
Yes, absolutely. It can't, with the bandwidth and with the latency, you need to make decisions in microseconds. So in those situations, or we can talk about other use cases later on, in those situations, it makes sense for that intelligence, that machine learning model to actually run on the device itself, on the edge.
So if I understood correctly, we train the model on the cloud, on these huge instances, huge machines, take the resulting artifacts of that and ship to a device that may be offline, for example, right?
Exactly, yeah, absolutely. So once you have all the intelligence in form of the model that you have created, which is the output from your training process, you can take that model, and you also need what's also called as the inference code. So a code that can actually call and use this model on the device. So once you have packaged these two things and deploy on the edge, you can actually run those models when you're even completely offline or disconnected from internet.
And how does it work? Like, what's the for the developers that are watching us? What's the workflow for this?
Yeah, absolutely. So I have actually a slide that kind of goes into a little bit visualization of that.
Let's see.
So here's, again, just to explain that the first thing is you need to build and train the models in the cloud. What's going to happen is, as you collect, before you can actually train, ideally you would be collecting all this data from your IoT devices.
Okay.
Let's take whether it's the robots in a manufacturing plant or drill machines on an oil rig, or whatever that machine is, you need to collect data, and ideally lots of that data. So
when we talk data here, you mean like numbers and tables or images or audio?
Think of this as the data we get from sensors, and think of this as a telemetry we're getting, because usually to do some of, and again, we are probably jumping ahead, but to apply these machine learning models and do things like predictive maintenance, anomaly detection, essentially we are trying to find a pattern in the data which the model hasn't seen before.
I see.
But for it to learn, we need to actually give it, and this is called supervised learning in machine learning, we need to actually be able to provide some previous historic data for it to then learn from.
I see, I see.
Yeah. So, and here what I'm trying to show is, but before you can actually build and train, you need a way to get this data into the cloud. Now you have different mechanisms depending on the use case. If you have IoT devices, you can run Greengrass, and through Greengrass you can push this data into IoT Core, which is our IoT cloud-based service. Or even if you, in cases where you're not using Greengrass, you can ingest this telemetry through IoT Core, or even other mechanisms we have for data ingestion. Again, it entirely depends on the use cases. But once you have data in the cloud, you can use SageMaker. I'll give a little bit of tour of SageMaker later on today. But SageMaker makes it really easy and really simple to build these models. It takes all the typical complexity and involved in creation of machine learning models. So SageMaker really simplifies how you can create these models. Again, I'll go into that a little bit later. But once you have trained them, sorry.
Just to recap to the current status. So data is flowing to the cloud through AWS IoT.
Yep.
And people can use SageMaker to understand the data and build the models.
Yes.
And SageMaker will also compile that or build the model and ship, so you can ship the artifacts to the device, right?
Yes, that's correct. So SageMaker will help you, take all that data which is coming through. You can do. It provides you hosted notebooks, which if you're a data scientist, you know what I'm talking about. These are the hosted Jupyter notebooks, where you can do data wrangling, understand your data before you actually get this through any sort of training. And that's where typically a lot of time is spent just to make sense out of that unstructured data that you're getting from your IoT devices. And you're right, that once you have trained your model, you will have an outcome in the form of a file, which you can actually run in the cloud, or in this case, take it to the edge through Greengrass, service that we have.
Oh, so I have a question about the latency. Like in the case of autonomous cars that needs very quick responses, just to make it clear, like how do we achieve that?
Sure. So think about this. If you're running Greengrass enabled device on a car, and with Greengrass, maybe it's worth talking a little bit more about Greengrass, and hopefully it'll start making a lot of sense. So Greengrass essentially is, what we have done is, we have IoT in the cloud. We have taken similar capabilities. So I'm talking about things like device gateway, things like having ability to take actions based on the telemetry. We have rules engine in the cloud, and we can run Lambda off those rule engine. So we can take a lot of these capabilities that the device gateway, or what we otherwise call as the broker, which helps communicate with the devices. We can also deploy Lambda functions on the edge devices. So we can write Lambda functions in the cloud, and through Greengrass, we can push these Lambda functions on the edge in the Greengrass. So Greengrass is essentially a binary. It's a software that you can download and deploy on your devices, and it gives you similar sort of framework, similar sort of components you can run on the device itself.
Okay, so resuming for Ron King, when you have Greengrass on your self-driving car, for example, the responses would be immediate.
Absolutely.
Because the ML model is running on the device.
Correct.
And when the model matches something interesting, for example, if you have an accident or a delivery, then you can ship your data to the cloud and do things asynchronously.
And I think the good thing here is you can, whenever the car can connect to the cloud, it can send that telemetry at whatever is the frequency appropriate in that use case. But it doesn't need to be connected to make those actions. I think that's the value proposition here. Think about if a car is inside a tunnel, no connectivity at all, and it still needs to make those actions that it would do otherwise when it is outside of the tunnel. We still need to run the same intelligence and with the same response time as we would expect.
Just to make it a bit more concrete, you have some examples or people that's doing this nowadays?
Sure, absolutely. I have a couple of examples that I'd like to pull out, actually. Hopefully it's visible on the screen. So this is a customer, Yanmar. It's a Japanese diesel engine and industrial equipment manufacturer. So they've been having this challenge around, it's kind of a precision connected agriculture use case, where they wanted to actively manage plant growth in greenhouses. So these are really high-tech green. I have a picture on the next slide, which I'll show you in a bit. And they wanted to deliver the right amount of environmental support in the greenhouse crops, so especially in green grass. You need to be absolutely precise, when to water and how much to water, and other ambience can have an impact on that as well. And they were looking for to run that intelligence, run that train models in the greenhouse itself. So here's a kind of a diagram that explains what's going on here. They have edge devices, and they have sensors and actuators. So this is an IoT-driven precision agricultural solution that's really helping farmers to make take more accurate decisions. In fact, machines are making those decisions in most cases without being always connected. So. And this is running Greengrass ML inference and the trained model on the edge itself. So that's one use case. I have another one here, which is a company called DFDS. So it's a shipping and logistic company. And they had this issue around, or the challenge around, they wanted to improve the energy efficiency and wanted to reduce the carbon footprint of the ships. And now ships, you can understand, it could be in the middle of ocean, connectivity you can't guarantee, right? So how do you actually still make those decisions? How do you make the right kind of local decisions with the connected devices on the ship? So again, they're using Greengrass ML inference to do precisely that. So they build ML models to predict the ship propulsion using the sensor data they're getting. So all the sensors, all the connected devices to the locally within the ship provides all that telemetry, and the decisions are made there and then, because machine learning inference is happening right on the device itself. So again, another good example of where you can run ML models locally, where you can train these models in the cloud but deploy them on the edge.
Cool, and you can totally see how hard it would be to have internet connectivity, and you need to exchange messages between devices, run compute, run ML, and now you can do that all on Greengrass. But for the developers that are watching us and thinking how to actually build this.
Sure. So let me give a very quick tour of the key things you need to actually do to just to get started with Greengrass. And later on, I can point to the Greengrass documentation where we have some get started guides just to make it easy. So let me come out of the presentation mode here, and so I'm going to open my AWS console here. So before I actually go into the console, the few links I wanted to point out for our audience here. We have a machine learning inference guide. It's a Greengrass developer guide, which I think it's a good starting point. Is this getting started? It explains you, before you even run ML inference on the edge, how to just go about setting up Greengrass on your device. I think Raspberry Pi and similar devices are very good for prototyping. But even if you do not have a physical device, you can try this on things like EC2, for example.
That's an interesting point. Like, what are the typical devices that you see running Greengrass as a gateway?
Oh, we have, if you go on a website, you'll see quite a big spectrum of partners we have around. There are a lot of partners who are working with us. In fact, deploying which comes pre-deployed Greengrass or which are compatible with Greengrass. Generally, we say it needs to be Linux-based, and it's compatible with the ARM and the other processor architectures. But there are more details in the documentation.
But a Raspberry Pi is okay.
Raspberry Pi is very commonly used by developers for prototyping purposes. And as I said, there's a list of other devices you can see on the website as well.
Correct.
Okay. So as I said in the beginning, assuming you have Greengrass deployed, and again, if you go on the IoT console, we provide you. If you go under the software section, we provide you all the software you need here, so you can actually download these binaries here, so you can get the Greengrass core software.
So can we just stop a minute and
Sure.
tell people what are the software that they can download there?
Sure. So this is, by the way, for those of you who are not familiar, this is our IoT console, and within IoT console, you can see the devices that you have provisioned and the state of those devices. Greengrass is one of the IoT services, and here you can set up your Greengrass core and Greengrass devices. If you go further down, we have a software section here on the console, and it provides you FreeRTOS, which is another kind of edge compute software for more constrained devices, things like microcontrollers, which you want to actually connect to the cloud or
Things
connect.
that can't run Linux.
Correct,
Right?
absolutely. So this is really for very much constrained devices, microcontrollers, essentially.
Okay.
And I think that's a whole big topic in itself, but FreeRTOS, just very quickly, is enabling those IoT use cases where traditionally it's been very hard to connect. I mean, think about from light bulbs to any microcontroller-based device, which has a very small compute and memory. How do you actually bring these devices online and do it securely?
Yeah, that's what I was saying, because most
yeah.
of them are perhaps limited enough to don't be able to do encryption and closing TLS connections and things like this.
Correct, absolutely. Then other software you'll find here is for the Greengrass itself. Then we also, and quite relevant for this topic, we also provide some the MXNet and TensorFlow precompiled libraries. Now, this is another challenge you get when you try to build and run models on the edges, especially if you're doing something like MXNet or TensorFlow. You need to bring those libraries, you need to compile them. That's another, so this is another kind of friction we are trying to take away from developers' life to make it easier to run deep learning models which are trained on MXNet and TensorFlow. And then you'll find other software SDKs here as well, which you will typically use on devices, your IoT SDKs, Greengrass core SDKs, for these devices to connect and communicate with IoT core in the cloud. Okay? So I'll come back to this console, but let me go back to the original discussion where we started from. Is before you can put anything on the Greengrass, you need to train the model.
Okay.
And this is where SageMaker comes in.
Let's see.
So SageMaker, it explains, let me try and make it a little bigger here. So as it explains on this overview, when you land on the dashboard, it's a managed service which provides you totally from the end-to-end life cycle of your machine learning models you can manage within SageMaker.
So in the end, you pick the model that's out of SageMaker, and you choose if you want to deploy it to the cloud or to Greengrass.
Oh, absolutely. And in cloud, you can actually, SageMaker is not just a model creation, but you can also deploy these models within SageMaker. It gives you an endpoint, which you can use through in a Lambda function or any API call. You can use these models in the real time. Or you can actually deploy them on the edge.
Let's take a look at one of those notebooks.
Sure. So the first thing you would typically do here is when you get started with Notebook is you create a Notebook instance. I have one already here. So just to save time, I think we won't create a new one. But once you, oops, I didn't realize it was already stopped. But once it comes online, we'll see it will open up a Jupyter notebook interface. So again, the good thing from, if you think from a data scientist or machine learning practitioner's point of view, or developers for that matter, you don't have to provision anything. I haven't gone and provisioned an EC2 or installed Jupyter Notebook. It's already built into the service. It's just pretty much one-click deployment.
Especially in this IoT case. I mean, just setting up the devices, installing stuff on the Pi, and setting up the Jupyter notebook with the machine learning libraries, MXNet, Gluon, and so forth can be
Absolutely.
like this huge amount of work, right?
Yeah, absolutely. So, so I'll wait while it comes online. But once you have the notebook, then what you can do is you can create jobs. These are essentially your training jobs. Now, you have two ways, actually, you can do this. You can use a notebook interface. Typically, if you are a data scientist and you want to do some data wrangling and play around with the data, notebook is an ideal kind of tool for you. But you don't necessarily need notebook. You can also train these models from the console itself. So, for example, I created this one directly from the console. So you can create a new training job. You can give that job a name, and you need like all services, we have IAM integration, so you need some IAM role for this job, correct. And you can choose which algorithm you want to train. Now again, this is where we have hugely simplified machine learning development.
Wow.
We are packaging already, I think, 10 or 11 different algorithms as part of the service. So the one I have in the example, I used linear learner because I was trying to create something that could do binary prediction. Equally, you could use, and some of these are very commonly used in machine learning problems, especially when you talk about predictive analytics, anomaly detection, things like linear learner, XGBoost, random cut forest for anomaly detection, so on and so forth. Or you can use things like MXNet. So it gives you already a head start in your machine learning programs. So
totally. And those algorithms were pre-built and optimized by Amazon, so many of them are streaming algorithms, meaning you can pass all your data that it won't accumulate in memory, so you can train with terabytes of data potentially, and this is very important for these cases. And once the model is trained, that's a key idea that I'd like to leave. You don't need the big thing is training the model. Like once it's trained, you can run the inference on the Greengrass devices,
Precisely.
and that's what we're talking about here.
Absolutely. So I know we have a few minutes left. So this is the kind of experience, the visual experience you get when you're.
Let's check if that notebook is up. We can show
yeah, absolutely. Let's
how
go back
it looks
there.
like. Right?
Oh yeah, it's in service. So I can so again, from a user experience perspective, if you're starting off with SageMaker, you just come here and create a notebook.
Perfect.
That's it. You choose what kind of instance you want to run in, and once it's provisioned, you just simply open it, and hopefully the Wi-Fi is not catching up, and then this is the Jupyter experience you get. So here, as I said earlier,
can you increase the font there a little
sure,
bit?
yeah, I think it's a little.
Okay.
Hopefully this is better. So here, as I said earlier, you get already some sample notebooks to get started. So when I click here, you'll notice some of these are, if you're new to SageMaker or machine learning in general, you can probably get started with some of these starter notebooks. So you can go into Introduction to Amazon Algorithms, and you can go through some of these sample notebooks which is out there. And it gives you sample code just to get you started, but you can then, from here, you can start tweaking them and make them fit for your use case. Absolutely. Yeah.
DeepAR, this algo that we just opened, is an algorithm for time series prediction, so it's kind of important for telemetry data and the data that you usually have from IoT. And it was released from a research paper 6 months ago, and it's already there and available for you to explore and use along with dozens of other algorithms that we have, right?
Yeah, absolutely.
Awesome. And we're nearly out of time. Is there anything else you'd like to
I think just one final point I want to mention is that the SageMaker experience is also integrated with our new IoT service, Iot Analytics. I know today wasn't the big focus on that, but worth mentioning that Iot Analytics is also something you should consider when you're trying to build analytical workloads around your IoT use cases specifically, because it will help you very easily process this data, transform and enrich this data, and very importantly, have native integration with SageMaker so you can run ML through the pipelines in Iot Analytics and then later on deploy those models on the edge or in the cloud is your choice.
Awesome. Perfect. Thank you so much, Niraj, for sharing this with us, and see you in the next session.
Thank you. Thank you very much.